All right, ladies and gentlemen, welcome to the second of 3 videos for Chapter 5, Section 1 in your geometry book entitled Bisectors in Triangles. In the previous video, we talked about perpendicular bisectors of line segments, and now we're going to extend that to talk about the perpendicular line segments of a triangle. Now, if we look at 3 or more coplanar lines, if we're talking about 3 lines in a plane, there's only 2 ways that can exist. Either those lines don't intersect or intersect at different points, or all 3 of them intersect at the same point. So that's what leads us to this new and fairly important vocabulary word of concurrent lines, which will be defined as, so here these 3 lines, L, M, and N, are concurrent lines. They all cross at a single point. So concurrent lines would be 3 or more coplanar lines that intersect at a single point. That point, in this case P, is known as the point of concurrency. So you'll notice that L, M, and N are concurrent lines. They all cross at point P. All right, so the reason we're introducing that vocabulary is that perpendicular bisectors, when we look at a triangle, there are 3 side lengths. So if there are 3 side lengths, that means there's 3 sides, 3 line segments, which means there are 3 perpendicular bisectors. So if we look at this picture, we have 3 line segments, or 3 perpendicular bisectors indicated in this picture. Let's call those 3 lines L, M, and N. L is the perpendicular bisector of side AB. M is the perpendicular bisector of side AC. And N is the perpendicular bisector of side BC. All of them are marked as being perpendicular bisectors as indicated by a right angle and congruence markings. Now this triangle is almost an equilateral triangle. I was off by just a little bit, which is actually significant when it comes to what I'm going to talk about, because it does kind of muddle things up a little bit. I probably should have made something that was significantly less equilateral, something that wasn't quite so close, okay? But you'll notice that the 3 perpendicular bisectors in that triangle, those are concurrent lines. They all intersect at the point of concurrency, X. X is called the circumcenter of triangle ABC. Now, the circumcenter is important because it has a property. The circumcenter X is equidistant, which is fancy talk for the same distance, from all 3 vertices of the triangle. Now, those line segments that I'm going to talk about here are actually not shown specifically in this picture. Okay, but what I'm saying is that if we looked at the distance from A to X, the distance from B to X, which is in the picture, and the distance from C to X, all 3 of those lengths are the same length. And in fact, this comes down to why it's called the circumcenter. That is called the circumcenter because X is the center of a circle that is circumscribed around the triangle. Okay? X is the center of the circumscribed circle for triangle ABC. If you look closely, you'll notice that the triangle only has 3 points on the circle, the 3 vertices. This is what an inscribed circle or circumscribed circle looks like, is a circle that passes through all of the vertices of that particular polygon. So X is the center of that circle, hence the circumcenter. It's the center of the circumscribed circle. Circumcenter is a vocabulary word, the big thing being that you need to know that circumcenter is related to perpendicular bisector. Okay? The circumcenter is the point of concurrency of the perpendicular bisectors. Now, some interesting facts about that. One, there is a theorem. The circumcenter theorem says that the perpendicular bisectors of a triangle intersect at a single point called the circumcenter that is equidistant from the vertices of the triangle. So in this picture, you'll notice DP, EP, and FP, which are the red segments are indicating the perpendicular bisectors. Those three come together at point P. Now what they've done is they've drawn in those distances from P to each vertex, PA, PB, and PC. All three of those distances are equal. That is what the circumcenter theorem states, that the distance from the circumcenter to the vertices of the triangle is equal. Now, less important but interesting is that the circumcenter, while it is one of four centers of a triangle, and we'll talk about all four of them over the next several videos, the next couple, the section and a half that remains in the beginning of chapter 5, is that the circumcenter, despite being a center of the triangle, does not actually have to lie in the triangle. If your triangle is acute, then the circumcenter will be inside of the triangle. If your triangle is obtuse, then the circumcenter will actually be on the outside or exterior of the triangle. And if your triangle is a right triangle, then your circumcenter will be at the midpoint of the hypotenuse every single time. So that's just an interesting little fact, something to keep in mind. That does it for our second video over concurrency and discussing how perpendicular bisectors in a triangle are equidistant from the points. We'll have one additional video covering the angle bisectors of a triangle, which, as it turns out, well, that leads to another one of our centers. Thank you very much for your time and attention.